So the next unit that we're going to focus on is called transformations. And transformations is basically moving things around. So we're getting a little bit more, of course, vocabulary to learn. So we need to learn how to speak in the idea of transformations. So that's what this entire lesson is about, learning the vocabulary. Make sure you get this information down. Okay, so let's take a look at some of our first vocabulary for transformations. Well, transformations, first of all, what is a transformation? Well, a transformation is nothing more than a way to move a figure, to move all points on a figure to a new figure. Okay, that's really all the transformation is. Okay, it's some kind of rule that we use to move a figure around. Now, there are different ways we can move the figure. You see, geometry, we're not just studying the figures themselves, we're studying how the figures move around. And that gives us that correspondence between 2 points, a figure and a new figure. The new figure is called the image. The original figure is called the pre-image. Okay, so that's some terms we got to know. We got to know when we're reading our problems what we're looking at, the image or the pre-image. Most of the transformations we're going to study are going to preserve shape and size. What that means is preserve, they keep. So they keep the size and they keep the shape. Now in mathematics, when we refer to size, we're really referring to the angles. I'm sorry, not the angles, the lengths. Okay, so size refers to the lengths of things. Shape refers to the angles. Okay, so preserving the size of things means all the lengths stay the same. Preserving the shapes of things means all the angles stay the same. Okay, these types of transformations are called rigid transformations. They're called rigid because rigid means stiff. It doesn't move. This pen is considered rigid, but this piece of paper is not rigid. Okay, so rigid is stiff and not moving. The big fancy word is isometries. Isometry. Okay, and the term isometry comes from the Greek. Okay, it comes from the Greek of same measure. So I'm going to actually put that in here. Nice little trivia. So it's just from Greek, meaning same measure. Okay, so that's where the term isometry comes from. We're going to talk about 3 types of isometries. Okay, 3 things that we can do. We can slide things, we can turn things, and we can flip things. Now, slide mathematically is a translation, taking that thing and sliding it over. Turning is rotating, and then flipping is a reflection. So these are the terms that you really want to know. We want to make sure that we have these terms, understand what they mean. Translation is a slide, rotation is a turn, reflection is a flip. And we're going to look at each of these separately. Okay? So without further ado, let's take a look at the first one of these. Let's talk about translations. When we translate things, really a translation is the simplest one to move, and really a translation moves an image along a vector. Okay? Now we might have to define a vector here, okay? A vector is basically it's represented by an arrow that shows direction and magnitude. That's a fancy word to basically say distance. Vectors get used often in physics. You'll talk about vectors in physics when you talk about things, pulling things. We talk about them when we do forces in physics. So vectors are very important. You also see vectors more in higher level mathematics. Now, what we're talking about with our vectors, we're talking about it moving along a distance. So basically, this point moves to that point. We can see the distance it moves and the direction. Okay, so that's basically a vector. By the way, that's important to know. Whenever we're doing these translations, the components of a translation, you need to know the vector. Okay, need to know the vector, which tells me distance and direction. So how do we perform this? Okay, well, let's take a look at a couple examples. Here's some examples on the XY plane. Okay, so here's our original, our pre-image. There's our image. And on all these, we can see B move to there, A move to there, C move to there. All of these lines are parallel to each other. They're all the same direction, and they're all going the same distance. The same can be true about this, D to D prime. So here we're going backwards down there. G to G prime, F to F prime, E to E prime. Notice that term I'm using, prime. So A to A prime. The prime lets me know that I'm looking at the image, not the pre-image. So the prime comes from the previous thing. Okay. If we were looking at this in basic pictures, okay, here's a little star. So basically, if I want to take that star and translate it, I could easily just trace the star. And I'll go ahead and make it look exactly the same. There's my star. And if I slide over, well, this distance I slid over right there is my vector. Okay, so that's telling me where I'm going. If I go in this direction, I'm sliding that way. Well, that kind of rotated it too. If I want to slide that way, let's say we took one and I want to take this image and go this way with it. Well, I would take my image and I would just slide it along there. Notice I didn't turn it this time. Okay, I just slid it along. So that's what we mean by sliding along a vector. So a vector is a slide, or a translation is a slide, rather. Okay, so there's our translations. Very simple process. Okay, like I said, we're just getting through some vocabulary. How about our next one? A rotation. Rotations you're used to. It's just turning. So a rotation is it moves an image around a fixed point. Okay, so that's what we mean by rotating our image. Now, there are some things that we're going to talk about with rotations, how they're different, and things that we can change and look at. But let's go back to our star. In fact, I'm going to do a new star here, okay? Let's get a new star. I'm going to copy my star real quick. So if I copy my star, and we're going to rotate this image. Now, with a rotation, we have two important things we need to have, okay? So we talked about the components of a translation. Components of a rotation require you to have a center of rotation and an angle of rotation. Okay, so you need to know where you're centering your rotation and how far you're turning. So if we take a look at our star again, here's my star, and I'm going to rotate that star. Well, I need a center of rotation, so let's center it right there. And for right now, we're not going to worry so much about a degree of rotation. So I'm going to copy my star. This is my prime star. There we go. And if I'm going to rotate that star, that means I'm going to keep this point the same. And as I turn, the star moves. So that would be a rotation. We can see the pre-image under here and the new image there. The degree of rotation, well, that changes depending on the figure. This one went around there. so I could figure out that degrees. Okay, this one went around there, so we can see how it sort of goes around. Okay, so that's all a rotation is rotating around the point a certain degree. The degree that we rotated is this degree right there. I'll call that theta. So that's our degree of rotation. It's the degree between that. It's that central angle, if we want to think of it that way. Okay, so the central angle is our degree of rotation. Okay, so that's really all there is to rotations. And like I said, during this unit, we're going to go into these in far more detail. So let's look at another one. Oh. Excuse the bell. So in our next one, we're talking about reflections. And reflections are ones you're used to. A reflection is a movement over a line or point, and we'll talk about that later in the year, or later in this lesson. Okay, so it moves over a line or a point. It's a flip. It flips over the line. We can see here it flips over the line, and then we can start talking about things like symmetry and organizations like that. We can even do this on the XY plane. In fact, we'll do all of these on the XY plane. So here I see this line across here, and I'm crossing the line. Neat thing to notice, if I connect my u to u prime, notice that we don't have vectors this time because they're all different distances. They are parallel, but they're different distances, okay? So, but the distance from here to there is the same, and we're going to talk about what happens with those, okay? So if we go back to our star, where'd my star go? Here's my star. And if I want to flip this star, let's say I'm going to flip over a line, okay? Let's go back to some clear paper so we don't have all that stuff on. Because in our reflections, we need a line of reflection to flip over, okay? So if we want to talk about the components for reflection, we need a line to reflect over. That's what we need when we're doing reflections. So when I reflect it, well, let's say I fold this right along that line, and I copy my star. My copy job isn't too great. Like I said, art was not my subject of choice. And now I come back over this way. Now I can see that it's reflected over the line. So that's how reflection works, okay? Simple process, okay? So that's reflections. They're just flips over the line, and you get the same figures. Remember, we said that they're isometries because they preserve the shape. They change the way they look. They change the way they're turned, but they keep the same shape. We can also combine these. If I combine a reflection and a translation, we get what's called a glide reflection. So this is a combination of a reflection and a translation. So if we look at the foot, if I were to take my piece of paper here and I'm going to copy this foot, there's one. I'm going to try to copy it the best I can. I'm not very good at it. And if I reflect over the line, I'm going to reflect it over the line. I can't pick the paper up. There we go. Reflect over the line. There's my foot. And then slide it. And then I can reflect it again and slide it. So that's what we're doing with a glide reflection. It reflects and glides. Reflects and glides. Okay? So that's all there is to that. Now, all of these were isometries. They all kept the same shape. The star never changed in any of these. We are going to study one that's not an isometry. And it's something you may have talked about before. A dilation. Dilations are non-rigid transformations. Non-rigid transformations do not preserve the size of an object. Okay, so a dilation is a great example of that, because a dilation is it's a how do we say it earlier? It's a movement of points to contract or expand about a fixed point. Okay, so with the dilation, we need our component. We need a center of dilation, one point that stays, and we need a scale. How big or small do I make this dilation? And that's all we really need for dilations. We'll talk about that in more detail, but it's a little harder for me to do with the patty paper. But we can see our pre-image, and then it gets smaller. So that's a contraction or a reduction, okay? By the way, the point that we're dilating from is probably going to be somewhere over here. So here's the fixed point that we're coming closer to and getting smaller. This one is an enlargement. So its fixed point is probably going to be somewhere about the same place, it looks like. I'll do it in a different color so we can see. So if I connect some lines here, I see that this is my center of dilation, and it gets bigger as it goes out. So a dilation doesn't have to grow right there. You think of your eye dilating, the center of dilation really is your center of the eye, and it gets bigger and smaller. Okay, so that's what we've got with transformations. I think you're going to have a pretty good deal with this. We'll work more in class, and we'll look at these in more detail. The first one that we're going to look at in class is we're going to really study reflections to start out with. So when you come back to class the next day, we'll look at some ways to do reflections. Okay? Hope you enjoyed this, and I will see you on the next class. Bye now.